Hello everyone, welcome to the new lecture session. In this session, will be a continuation of the earlier lecture. So in earlier classes or session, we have studied about specific heat and the classical theory, its achievements and failure. So what was the classical theory? Classical theory was dependent on the equipartition energy theorem, and it leads to Dulong-Petit law, which states that total specific heat or lattice heat capacity is constant given by 3R independent of temperature and frequency. So these results matches with the experimental value only at room temperature or at higher temperature, but it fails miserably at lower temperature, where it is seen that experimentally specific heat is dependent on temperature. So as T decreases, Cv decreases, and ultimately as T tends to 0, Cv tends to 0. So this is not explained by Dulong-Petit or classical theory. You can revise that lecture now. So to overcome that, or as a modification of that classical theory, quantum theory of specific heats were developed. Okay, so specific heat of solid. So classical theory was there earlier. In classical theory, it is Dulong-Petit law. So specific heat was Cv was 3R, so it was a constant. So it agrees at high T only, but Cv dependent on T fails to explain Cv dependent on T. So if you take just as a revision, you can check. So as Cv, if we function of T, so it was constant at 3R. At high T, it agrees in the high T, but as T decreases, it fails in the low T zone. So to overcome this, quantum theory was developed. So first quantum theory of specific heat that we will be discussing is given by Einstein theory of specific heat. Okay, Einstein theory. It is given by Einstein on the basis of assuming some of the quantum concept or quantum phenomena. So there will be some assumption of Einstein theory. First we will discuss the assumption, then we will derive the equation. So you have to remember, because many times it is asked, অনেকবার জিজ্ঞেস করা হয় যে কি অ্যাজাম্পশন ছিল আইনস্টাইন থিওরিতে, সেই অ্যাজাম্পশনগুলো বেসিস করে ডেরিভেশনটা করা হয়। সো ফার্স্ট উই হ্যাভ টু নো দ্য অ্যাজাম্পশনস। সো ক্লাসিক্যাল থিওরিতে কি অ্যাজাম্পশন করা হয়েছিল যে অ্যাটমগুলোর মধ্যে, ক্রিস্টালের মধ্যে অ্যাটম আছে, অ্যাটমগুলো ক্লাসিক্যাল হারমোনিক অসিলেটর ছিল, সেগুলো ভাইব্রেট করছে 3 ডিরেকশনে। সো ইফ n number of atoms, we have 3n degrees of freedom. This was taken in classical theory. So this same concept is used here, but here the classical harmonic oscillator are replaced by quantum harmonic oscillator. So quantum phenomena or quantum results we have to use. So this you have to remember, that classical oscillator are replaced by quantum oscillator. This is the first things that is done in the Einstein theory. Then other things are identical, that atoms are vibrating about their equilibrium position. This is same assumption. Okay, so for n atoms, 3n, you can consider 3n one dimensional harmonic oscillator, but here it will be quantum. Okay, means total degrees of freedom 3n degrees of freedom we take. So instead of, for simplification, we consider one dimensional oscillator with 3n vibrational mode. Okay, so these are taken from classical theory, and few things are replaced is that we have to use the quantum results. So here, due to quantum mechanical nature, this oscillator don't have all all values of energy, all energy values not allowed. So this is very important. So here what we have discrete allowed energy states, or we can say discrete energy spectrum. So this is the quantum phenomena of that energy is discrete. So in case of classical, we consider continuous allowed value 0 to infinity, any value, but here the oscillator can vibrate with certain fixed frequency or discrete frequency. Now here one of the assumption is also taken same as Dulong-Petit law, that due to identical environment, all oscillators vibrates with same natural frequency omega 0. So here the frequency of vibration of entire lattice or all the atoms taken together to be equal to natural frequency of the lattice. So here same frequency is considered for all the lattice vibration. So whenever all the atoms vibrate, they vibrate at the same frequency. So these are the few of the assumptions. So classical oscillator replaced by quantum. So here also we have 3 and 1 dimensional oscillator, 3 and degrees of freedom. Here also due to quantum mechanical we have discrete values. So all values not allowed, discrete value, and frequency same. And other assumption is obvious. Here also Maxwell-Boltzmann distribution law of energy is considered, means a number of oscillator at particular energy is proportional to the power minus e by kt. These format are Maxwell-MB distribution law. So these are the few basic assumptions. On this basis we will now derive the results for Einstein theory of specific heat, that is the first quantum theory of specific heat. So okay, now we move to we proceed for derivation of Einstein theory. So here, according to Planck's theory of quantum radiation, actually Planck's first derived the Planck's law of radiation in case of thermodynamics using mixture of classical and quantum concepts. So in that case, energy of an oscillator, harmonic oscillator, is given as ANH nu or ANH cross omega 0, where we consider this as the natural frequency, n are the quantum numbers, any integer number. So here energy, only discrete value of energy is allowed, some integral multiple of h nu. So h nu is the minima quantum of energy. So this is the discreteness. So energy can be either absorbed or emitted in form of h nu. Okay, so this is due to given by Planck's theory. So this is the one of the expression of energy we can use in case of quantum theory. And another is using actual quantum mechanical consideration, actual quantum calculation. Actually Planck's law was an approximate where classical and quantum concept are mixed, but using actual quantum concept also, the energy of harmonic oscillator is found out to be half h cross omega h0. So here an extra term. So if we split this, what we will get, n h cross omega 0 plus half h cross omega 0. So here comparing this expression 1 and this expression 2, we will find that only this is an extra term. So this half h cross omega 0 is called the 0 point energy. So this exists at even at t equal to 0 Kelvin. So even at t equal to 0 Kelvin, the energy of lattice vibration is not 0. So there is some minimum energy that always exists in lattice vibration. So this you just remember. So this is a constant value, just the energy is changed by a constant factor, rest of the things are same. So even if we draw the calculations, all calculations is doing, only a constant factor due to this will come into play. So this will have no effect on our ultimate results. You can use any two equations. So we will be using the more general expression or this quantum mechanical expression. So now average energy of harmonic oscillator, similarly we have done in case of equipartition theorem. Here rather than integration we will have summation, because here we have discrete energy value. So it will be En to the power minus En by kT, okay, by n equal to 0 to infinity e to the power minus En by kT. So here what is En? En is the this expression we will use, second expression. You can also use first expression. So this expression we will use, and these are the Maxwell-Boltzmann distribution law. So using this we will find the equation. So now we will substitute 2 in 3. So if you put this here, so what will be the average energy? So you put it, summation will be 0 to infinity. I am not mentioning that, half h cross omega 0 to the power minus n plus half h cross omega 0 by kT by summation over n over all n. So e to the power minus n plus half h cross omega 0 by kT. We can simplify this, or we can write this as, we can take h cross omega 0 outside of the summation, and if we write summation, n plus half will be there, and we will write n plus half x. Instead here we will write n plus half x, here we will write to the power n plus half x. So what is x? If you take x equal to minus h cross omega 0 by kT minus this factor, so this will be x. So this term you can check easily, this will be x, and this term, this will be x. Okay. Now what we will do, you see in the earlier slides, here n equal to 0 to infinity. So now we will put n 0, 1, 2, 3 like this. Here also we will put n 0, 1, 2, 3 like this, and we will do some algebraic calculations. So if you put n 1, 2, 3 like this, so what we will get? We will get epsilon bar the left side, h cross omega 0 is constant, we will get two factors. So if you put 0, it will be x by 2 plus 3 by 2 to the power 3x by 2 plus 5 by 2 to the power 5x by 2, like this, and so on in the numerator. And the denominator, if you put, you will get like this. So you simply put this. So you see one interesting thing. So this you can write like this: d2 dx ln to the power x by 2 plus e to the power 3x by 2 plus e to the power 5x by 2. This we can simplify. So ln x, so we know d dx of ln x is 1 by x. So now if you differentiate this, you will get the numerator, and again you differentiate each of the, by chain rule you differentiate each of these. So for first term you will get half to the power x by 2. Okay, so next you will get 3 by 2 to the power x. This differentiation will be to the power x and constant factor half 3 by 2 like this. So this will be simply dt of dn x. So this is some tricks to simplify the results. So many ways you can simplify this. So then we will again simplify this ln. So now we will take e to the power x by 2 common. So this will be 1 plus e to the power x plus e to the power 2x plus like this, 3x, 4x, 5x like this. You take, so first term will be 1, then it will be e to the power x, okay, 1 plus half, then it will be 2 plus half. So like this you take this. So now this will be again ddt of ln e to the power x by 2 into, this is a two terms factor, so ln into a into b. If you have ln a into b, so ln plus ln 1 plus e to the power x e to the power 2x like this. So this terms. Now ln 1 plus e to the power x plus e to the power 2x dot. This expression you have to remember some of the direct results also. This will be given by minus ln 1 minus e to the power minus x. So this result you remember. So this we will substitute here. So what we will get, h cos omega 0 ddt of ddx of ln e to the power x by 2. Okay, ln e to the power x by 2. So we will substitute this. So what we will get? We will get x by 2 minus ln 1 minus e to the power minus x. Okay, so ln and e will get cancelled. We will simply have x by 2 and this will be this term. So you just substitute in this expression. So you get this. So this is again average energy. So now what will be this value? You further simplify this. ddx of x by 2 will be obviously half, and this if you substitute ln x is 1 by x, so it will be minus e to the power x. Again if you take minus or minus a plus, it will be e to the power x. Okay, so e to the power x. Now if you further simplify, h cross omega 0 half plus, if you take e to the power x in the denominator, it will be 1 e to the power minus 1, like this. Okay, now if you substitute this x factor, so h cross omega 0, it will be half plus 1 by e to the power x was what? X was h cross omega 0 by kt minus. So if you put this minus minus will plus, so it will be h cross omega 0 by kt minus 1. Okay, so this will ultimately be half h cross omega 0 plus, so if you separate this factor, h cross omega 0 e to the power h cross omega 0 by kt minus 1. So this is our expression for average energy of harmonic oscillator due to so you can give it equation 5 or serially whatever equation you give. So this is an expression for average energy of a harmonic oscillator taking into consideration of quantum mechanical expression of energy, and this is the average energy. Okay, from this now you see one factor, this factor is coming half h cross omega 0 due to 0 point energy. Similarly, if you take En equal to an h cross omega 0, you will obviously find, you can try yourself, that E bar will be h cross omega 0 by e to the power h cross omega 0 by kt minus 1. So this factor will be there if you take En equal to n h cross omega 0. So this is very simple. So in case of exam, you can either take this or that. So better you take n plus half. This will give you more accurate results. Not more accurate result means it will be better if you use general formula. Both are okay, but you should prefer to write n plus half h cross omega 0. Okay, so this is just a constant factor. Okay, so you remember this. So you remember this formula, these techniques, these tricks. Okay, so this is Einstein theory of specific average energy according to Einstein theory. So now what will be the total energy? 3n total vibrational mode, and we have average energy, so it will be 3n E bar. So 3n what expression we have? Half h cross omega 0 plus h cross omega 0 by e to the power h cross omega 0 by kt minus 1. This is expression. You put it, so E will be 3 by 2 n h cross omega 0 plus 3n h cross omega 0, simply multiplied by, to do this. Okay, so what will be now? So this is expression for energy, so you can give it equation 6. Now what will be the specific heat? Specific heat will be UDT at constant volume. So now if you differentiate this, obviously this is a constant term, this will have no effect on specific heat. So this is not important, so result will be same, but only energy will be shifted by some constant factor, that is the 0 point energy. So this will no factor because no T is there, only T is here. So what we will get, 3n h cross omega 0 by kt whole square. Here we have divided and multiplied by 1k for simplifying the result. So it will come out like this. So this is very easy. This, if you take this into numerator, so this will be minus 2, so this will come into the denominator. Then again you by chain rule you differentiate this, so here will be h cross omega by kt. So already we have 1 h cross omega, so you take 2, okay, so multiplied by k, so you take in a simplified form h cross omega kt square, and this will be this, this will be this, okay. So h cross omega by k will come out here, and you already have, so if you want to square it, you just simplify this, you will get this results, okay, no problem. This derivation you can do as a part, no problem. So here we use a symbol, theta e, which we call h cross omega by k, this factor. So these three are constant or characteristics of a particular vibrational frequency. If this is known, omega 0, then h, k are constant. So this is called a characteristic temperature, or it is called Einstein temperature, okay. So this is the Einstein temperature. You should remember this formula. This is the Einstein temperature, okay. So in terms of Einstein temperature, if we write the expression 3n k theta e by t whole square e to the power theta e by t e to the power theta e by t minus 1. So this comes into a nice form, okay. So this whole square, so this will be equation 7. So this is, you see, specificity is dependent on temperature and also frequency, so it dependent on temperature. So now in classical theory there is no dependence, but here we get dependence on temperature, okay. So this is Einstein theory of specific heat. So this is the derivation of lattice heat capacity at constant volume, specific heat at constant volume. Now if you take molar specific heat, obviously nk will be r, 3r theta e by t whole square to the power theta e by t to the power theta e by t minus 1 whole square. So okay, so you remember this expression. For many times numerical were also asked, এখান থেকে numerical আসতে পারে যে Einstein temperature frequency এত হলে h you know, k you know, you find theta Einstein temperature. So এই ফর্মুলা দিয়ে Einstein temperature বের করতে পারবে, ঠিক আছে। টোটাল এনার্জিটা আমরা পাবো, স্পেসিফিক এটা পাবো, ওকে। ফ্রম দিস we will now find two approximations to get an idea of matching with the experimental results. At high temperature what happens, at low temperature what happens, we will see, and also at t tends to 0 what happens. So we will see whether this predicts the nature of variation of specific heat with temperature. One thing it easily predicts that specific heat is dependent on temperature, so that is not given by classical theory, but here we derive that, okay. So in the next slide we will see the limiting values, high temperature, low temperature, t tends to 0, like this, okay. So what is our expression for CB? CB was 3nk theta by t whole square to the power theta by t, or simply you can write it to the power theta by t minus 1. For simplification we will write every time the theta in case of Einstein, okay. So when t is large or high value of t, so when t is large, so kt will be very much greater than h cross omega 0, okay, or t will be very much greater than h cross omega 0 by k, or t will be very much greater than theta. So this we know, or theta e, we will write equivalently theta or theta e, so notation is not, does not matter. So you should remember this, এখানে আমরা কোনো সময় theta e ইউজ করতে পারি, তো মনে রাখবে এটা একই জিনিস, বারবার লেখার জন্য আমরা সিম্পলিফিকেশনের জন্য theta we can use. So এটা যদি হয় তাহলে e to the power h cross omega 0 by kt, এই যে এটা হবে, এটা কি হবে, e to the power theta by t. সো এখানে টি যদি ভেরি গ্রেটার দেন হয় তাহলে এটাকে যদি টু দি পাওয়ার এক্স ফরম্যাটে লিখি তাহলে এক্স হচ্ছে লেস দেন 1, ওকে। সো এক্স লেস দেন 1, তো এরকম যদি হয় কোনো কিছু টু দি পাওয়ার এক্স লেস দেন 1 হলে আমরা এটাকে 1 প্লাস এক্স স্কোয়ার বাই ফ্যাক্টোরিয়াল 2 এইভাবে লিখতে পারি। তো ইফ উই কনসিডার দিস, দেন ইফ উই রাইট দিস, সো ই টু দি পাওয়ার এইচ ক্রস ওমেগা 0 বাই কেটি মাইনাস 1, এই যে ডিনোমিনেটরটা কত হয়ে যাবে, ভেরি নিয়ারলি ইট উইল বি ইকুয়াল টু 1 প্লাস এইচ ক্রস ওমেগা 0 বাই কেটি, উই অনলি take first order, plus dot 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 minus 1, okay. So this will be, so 1 1 will cancel, so this will be very nearly equal to h cross omega 0 by kt, means only x, e to the power x minus 1. So e to the power x minus 1, if you take here you will have x plus dot 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 minus 1, so it will be simply x. So this is just an approximation at high temperature value, so this will give me this. So what will be the cv value, or you can find the total energy also you can find. So what will be the total energy, half h cross omega 0 was there, then there was h cross omega 0 and it was h cross omega 0 by kt minus 1, okay. So this was the expression for total energy. So what will be the energy expression, what we will get in this case. So this will be reduced to half h cross omega 0 plus h cross omega 0 will be there, and this will be simply h cross omega 0 by kt. So this will get cancelled, so this will be half h cross omega 0 plus kt. Now as kt is very greater than this, so this will be very nearly equal to kt. So you get total energy as kt. So this already we know that average energy, so average this actually the average energy expression, okay. So total energy, if you find total energy E, you will find that it is 3n kt or 3RT, okay. So this will be same thing, you multiplied by the 3n, only this kt you multiply with kt, 3n car total per mole if you take 3n kt or 3n. So this is Dulong-Petit law. So we derive Dulong-Petit law. Now when t is small, if t is small, what will happen, you will get the reverse one, that theta very greater than t. So in that case what will happen, if theta is very greater than theta by t will be very greater than 1, so we will neglect the 1 in the denominator. So what will be the expression for the energy expression, so half h cross omega 0 plus, here it will be h cross omega 0, and here we will neglect the 1, we will only have h cross 0 by kt. So this will be very nearly equal to half h cross omega 0 plus h cross omega 0 e to the power minus h cross omega 0 by kt. So here you see this is a constant factor, so average energy. So this energy is dependent exponentially on the temperature. So as temperature rises, so if temperature rises, energy, sorry, if means temperature, if temperature decreases, this increases minus factor is also average energy also decreases. So there is temperature dependent on energy. So this is the one of the factor we will get. So what will be the specific heat? Specific heat, you know, it is dE dt. So half will get cancelled, so you know it is dE dt at constant volume. So half factor will gone, and only we will have 3 n k h cross omega 0 by kt whole square to the power minus h cross omega 0 by kt. So if you have expression for energy as half h cross omega 0 plus h cross omega 0 to the power minus h cross omega 0 by kt into 3n. So you have total energy like this. So you will have 3n and you will have 3n. So now this will be, differentiation will be 0. Now this 3n k will be there, and h cross omega 0, this differentiation will be in this, and we will additional have h cross omega 0 by k. So h cross omega 0 by k, and if as you are differentiating with respect to 1 by t, so it will be minus 1 by t square. So minus will be plus, and we will have t square. So this is the expression for specific heat. So you see here the dominating factor, as theta is less than t, this exponential factor will be dominating. So specific heat So we can say as temperature decreases, specific heat decreases exponentially. So here variation, how will look like? So it can explain that at high temperature it agrees with Coulomb-Petit law. Suppose this is the experimental curve. Suppose this is the experimental curve. So at high temperature, this Einstein equation agrees. Now this also agrees. As it decreases, specific heat also decreases. Okay. Specific heat also decreases. So this nature also we get. Now as t tends to 0, what will happen to Cv? As if t tends to 0, 0 minus infinity, so Cv will goes to 0 automatically. So Cv will go to 0 automatically. So low temperature and high temperature and intermediate temperature predictions are correct, but you should remember prediction is correct means at high temperature it is constant. So some of the achievement, so if achievement you are asked some of the results, so Einstein theory agrees with experimental results at high temperature, give rise to Coulomb-Petit law. Okay, it also predicts decrease of Cv with decrease of T. It also predicts Cv tends to 0 as T tends to 0. But what is the drawback? Drawback is value does not agree with experimental result at very low temperature. At very low temperature, there is some kind of deviation occurs. So at very low temperature, if you take into low temperature zone, if you write here Cv, if you write here T, so what will happen? So suppose you have 3 hours, so suppose you have this as the experimental curve. So Einstein theory fails in case of, so this here occurs deviation. So Einstein theory fails in the low temperature region where it deviates strongly from the experimental curve. Actually it is seen that Cv is proportional to T cube. So Cv decreases in the form of T cube law at low temperature, which we will see further modification of the Einstein theory by Debye theory. So okay, so why this drawbacks? So drawbacks is that it can explain the variation and can predict, but over a wide range, but it fails at very low temperature zone. So why it fails? Because there is some assumption that all failure, why it fails? Failure reasons, all oscillators vibrates independently. So this is one of the wrong assumption, because oscillators are actually coupled oscillator, as we have seen, or coupled vibration in case of lattice vibration. So this is taken into consideration by Debye. So this is the assumption. Then again, frequency is considered same. So this is again wrong. So here we consider a distribution of frequency spectrum. So a range of frequency should be considered. Okay. So there is no independent vibration, there is coupled vibration, and frequency will be, there may be defined mode of vibrational frequency. Okay. So these things are taken into consideration further by Debye, and a further improved derivation formula is given for specific heat, which agrees very well with the experimental results at higher, intermediate and lower temperature. There we will find out the Debye T cube law in the next class. Okay, thank you.